Hello guys, welcome back to our YouTube channel. In this video, we are going to discuss two concepts in the chapter Motion in a Plane of class 11 in terms of some standard questions that keep appearing in NEET. So let's move to the first question. The first standard question would be a boat or a swimmer crossing a river, and many students find this sort of tricky, but there's a pretty easy trick. The first type of question that they ask in this is that the swimmer should cross the river in the minimum time. So the easiest trick for this is that to cross the river in minimum time, the swimmer should have the maximum possible velocity in the vertical direction, because the time is equal to the distance, that is this much, distance divided by the velocity in the vertical direction. So we'll write VV, that is velocity in the vertical direction, and among the velocity of water and the velocity of the man, it can only be the velocity of the man that is in the vertical direction, because the velocity of water is in the horizontal direction itself. So for V of vertical direction to be maximum, the resultant of the velocities of the water and the swimmer should be maximum in this direction. So the swimmer should swim in this direction. Let's write Vs as the velocity of the swimmer. So if the swimmer swims vertically, he will reach the opposite side in the minimum time possible. This is the velocity of water. So obviously there will be some drift and he won't land exactly opposite to where he was, because there is a horizontal component into water's velocity. But to reach the opposite shore in the minimum time possible, he should put all his effort to swim in this direction. So if he swims in this direction, the resultant velocity, that is the V S vector plus VW vector is equal to V resultant, would be in this direction depending on the magnitude of the velocity, and he would be able to reach in the minimum time possible, and that would be D divided by Vs. So suppose there's a question in which they give that the water is flowing at a rate of 5 km per hour is equal to VW, and 3 km per hour is equal to V swimmer. So the question is, what is the minimum time in which he can cross a river which is having a width of 1 kilometer? So no, let's keep it 9 kilometer. Right. So to solve this question, we use this standard derived formula that we have used just now based on logic, and we write dt min is equal to D divided by Vs, which is equal to 9 kilometer divided by 3 kilometer per hour, is equal to 3 hours. Okay, so this is how we solve this question, and in this case, if you wanted to find the angle that it makes with the horizontal, then you can always consider this right angle triangle, which goes like this. Once again, I'll just draw it up here. This is VW, this is Vs, and this is V resultant. So it is this angle that we want to find. This is theta. So tan theta is equal to Vs by Vw, which is equal to 3 by 5. So theta is equal to tan inverse of 3 by 5. So that's how we find the angle, and that's a condition required to cross the river in minimum time possible, and the same thing applies for a boat as well. So next we'll discuss about how is it possible for the swimmer to reach the point exactly opposite, that is his drift should be minimum. So now let's discuss the case of minimum drift. So drift is symbolized by this symbol delta, and It means the distance that is moved with respect to the original position as measured from here. And delta minimum refers to minimum drift possible, that is when the swimmer goes exactly opposite to where he started from, that is delta min, which is equal to 0. So many questions are asked based on minimum drift. So let's see the easiest trick that is used to find the velocity, find the angle at which the swimmer must swim for minimum drift torque. So the idea behind minimum drift is that the resultant velocity Vr, which is equal to Vs plus Vw vector, should have no horizontal component, because its entire velocity of V resultant should be in this direction, that is a vertical direction, because we want it to go exactly vertical and there should not be any horizontal component of velocity. So the horizontal component of the velocities should cancel. So the two horizontal components that we would have are Vw vector itself and the sine component of the Vs vector. So it would be Vs sine theta. So Vw has to be equal to Vs sine theta. And this is the basic formula on which all minimum drift questions can be solved. And so let's try to apply this in a question. So the question says that V of the velocity of the swimmer is 5 km per hour and the velocity of water is 3 km per hour, and he goes at minimum drift, that is he lands exactly opposite to where he started. So the question is to find the angle that the swimmer makes with respect to the horizontal. Suppose this is Vs and this is the horizontal, they are telling to find this angle. And this will become possible if we find the angle of this with the vertical. Let's name this as theta dash and add 90 degree to it, because this would be vertical and this is horizontal, so this angle is anyway 90 degree. So to find theta dash, we use the same condition as we had written over here. So we write Vw, which is 3, is equal to 5, that is Vs, into sine theta dash. So by this we find that sine theta dash is equal to 3 by 5, and if you know the value of theta for sine inverse 3 by 5 would be 37 degrees, so theta dash is 37 degree. And to complete the solution for this question, we need to find the entire angle theta, which is equal to 90 degree plus theta dash, which is equal to 90 degree plus 37 degree, which is equal to 127 degrees. So the angle that the swimmer should make with the horizontal while swimming would be 127 degrees, and this is how you can easily solve such minimum drift question. Please do like and share the video and subscribe to our channel.